Hi everyone. Let us start with SetLanguage exercise 1.2, question number 5 today. State which of the pairs of sets are disjoint or overlapping. So first we have to check what is the meaning of these two things, disjoint or overlapping. So first see what is a disjoint set. Disjoint sets means if two sets do not have common elements. If suppose your set A has two elements 1, 2 and your set B, let us take this as an example, has two elements 3, 4. They have equal number of elements but not same or does not contain any common elements also. At least if one is there, then you cannot say it as a disjoint. So that is the meaning of do not have no common elements, no elements in common. Obviously, A intersection B will be equal to pi. So now overlapping sets. Overlapping sets are the opposite of disjoint sets, which means if they have at least one element common. If suppose this has 3, so then 3 is here, 3 is here. So they have at least one element common, then A intersection B is not equal to pi, we write it as 3. So those are called overlapping sets. They can have more than one also, like they can have 4. But the main thing is at least one. Minimum one should be there. So that is the meaning of disjoint and overlapping sets. With this quick recap, let us go to the questions. Let us write the solutions for this. The first question is set A is equal to FIAS, set B is equal to ANFHS. First of all, let us try checking whether it has any elements in common, which means A intersection B. F, let's take F. Do we have F here? Yes. So we'll write F here. Then let us check the second one. I. Do we have I here? No. Then let us check A. Do we have A here? Yes. A is there. So we can write A here. And then yes. Yes. So they have three elements in common. So we have studied like if there is more than one element common, we can write it as it is an overlapping set. So this is a overlapping set. Here A intersection B is not equal to pi. It has some elements. So it is a overlapping, these two are overlapping sets. Now let us move on to the next question. See, here the elements are not given directly like question first. So let's move on to this and read it. X such that x is a prime number which is greater than 2. So we have to satisfy two conditions. Let's start with our prime number. The first prime number is, yes, it is 2. But here it is given greater than 2. So we can't write 2. Let's go to a number which is greater than 2. Like 3, 4, 5, sorry, not 4, 3, 5, 7. And it goes on like that. So 3, 5, 7, it is the prime numbers list. Let us stop here as of now and let's move on to set D. D is x such that x is an even prime number. So we know there is only one even prime number. What is it? Yeah, 2. So now if you see these two sets, C and D, let us try checking for common elements. So in D, if you see there is only one element and let's see whether we have this 2 in C. Do we have 2 in C? No, we don't have. So now our C intersection D is null set or empty set, which is pi. So what happens if we have it as pi? These are disjoint sets. Disjoint sets are nothing but if there is no elements in common, then it is called as disjoint sets. Now, let us move on to the third question. Solution for this is little trickier than the other two questions. So let us start. E is equal to factor of 24. Do you remember what is the factor? Yes, it is nothing but when you multiply any two numbers, and if you get this number, whichever you want to find factor, those two numbers are the factors of the number. For example, 1 is a factor of all numbers. So 1 into any number gives the same number. So now we find that these two are factors of 24. 1, comma 24. Now, let us check for 2. 2 times 12 is 24. And then 3 times 8 is 24. And 4 times 6 is 24. To get it in ascending order, I have written it like this. Or you can write 124 to 12 and take a second step also to get it in ascending order. Both ways it works. It's not a mistake. So now let us move on to the next set. F is equal to multiples of 3, and what is if they stop here, that is not a, is it a finite or infinite set? It will be an infinite set because it goes on. But they have given another condition, x is less than 30. So let us start writing the multiples of 3. 3, 6, it's nothing but the tables. If you say the tables, you'll get these numbers. 1 3 is 3, 2 3 are 6, 3 3 are 9, 4 3 are 12, 5 3 are 15, 6 3 are 18, 7 3 are 21, and 8 3 are 24. So now if you check, we have to see for the common terms in these two sets, E and F. So let us check. 1, we don't have 1 here, but the 2 is also not there, but we have 3 in both the sets. And also 4 is not there, 6 is there. 6 is there in both the sets. Now if you go for 8, it is not there, 12. So obviously now itself you can decide that the set is not a disjoint set. We have got 3 elements. Anyways, we'll still continue checking for all the elements. 24, and we have got 24 in this set also. So if I go here, we'll write our intersection first. E intersection F is equal to 3, 6, and we can just put dots, or you can write the elements also, because 1 is more than enough to decide whether it is, the question is just disjoint or overlapping. So 3, 6, 12 and 24. So now our E intersection F is not equal to pi. So which means if it is not equal to pi, it is again overlapping. Overlapping means it is having one element in common. If you take 2 sheets of paper and keep on one top of it, a little sheet, if it is on the top of another sheet, it stays overlaps. That is the literal meaning, like this. If I put a sheet here, another sheet, if it touches, this area is the overlapping area. So in the similar way, 2 sets are overlapping. Here we see with elements. So with this, I conclude. So hope you understand the question. And in the next slide, I'll give a clear note of this, and you can make a note of it in your homework. Thank you. Bye.